All right. Good morning this morning to you, everyone, and welcome to another session with Mr. Hunt as Tipper Tutorial. Okay. Based on our last class, is there any question from one or two students that you need an idea or an understanding on GP? Let me know. I will mute the mic now to hear your feedback. Is there any question based on our last topic? Anyone? Any question? Okay. In the absence of no question, I'll bring out a question that will buttress our point based on our last topics. So that will introduce us to the new topic we are in for today. Okay. Is anyone here? Okay. I start. Series. And still on the geometrical progression. Okay. Still on the geometrical progression, I bring out a question on geometric progression. Then we move forward. Yeah. Looking at my past question, I have a question 50 on your page 79. Question 50, page 79. Something I can write. So let's see. The second and fifth terms of the geometric progression are 6 and minus 48, respectively. Let's start. The first term is so the question asks us to find the first term instead. The question requests for the first term instead. And mind you, based on the knowledge of GP on our last class, we know that the general term for a GP, Tn is given as ARn minus 1, where we have Tn to be the number of time in each sequence. A is the first term, R is the common ratio, N is the time itself. So yeah, we say that what? The second term, T2, which is given as AR, is denoted by 6. And the sixth term, or fifth, which is AR raised to power 4, is given as minus 48. These two are given in the question, and we are told to find the value for A, the first term. So all we need to do is just solve them simultaneously. We call the first one equation 1, we call the second one equation 2. Now, how do we solve simultaneously? You subtract or you divide, or you multiply or you times. Now, looking at this, we have AR. We have AR raised to power 4. So how can we do solve this one simultaneously? We do what? We subtract both sides. Subtracting both sides, divide both sides. Dividing both sides will help us to omit our multiplication sign. So dividing both sides, that's it. Equation 2 from equation 1. We have A, we divide A to be what? Out, which is 1. So let me put a 1 there, invisible 1. Then we have R raised to power 4 divided by R raised to power 1 equals to minus 48 divided by 6. So here we end up having R raised to power 4. Our division changed to a minus, which is R raised to power 4 minus 1 equals to minus 48 divided by 6, end up giving us a minus 8. So here I have R raised to power 3 equals to minus 8. And here, R raised to power 3 equals to minus 3. What is that value that when we raise to the power of 3 will end up giving us a minus 8? To find out yourself, then it can get us giving us what? R raised to power 3 equals to minus 2 or raised to power 3. Because minus 2 times minus 2 will give you a plus 4. And a plus 4 times minus 2 will give you a minus 8. So that tells you that what? The value of our R end up to give us a minus 2, which is the common ratio for the question. But the question is asking us for the first term. So how can we find the first term? We say put or substitute value r equals -2 into any of the equation, 1 or 2. So equation 1 is very simple. So I go with equation 1. So that becomes AR equals to 6. The value of A is unknown. My R is -2 equals to 6. That means divide both sides by -2. Then my A equals to -3. And that is the final answer. Is there any question relating to this question I just finished? Or you want us to move ahead? Please, let me hear your feedback. The mic is on. I need your feedback. Any question relating to what I just finished, or you want us to continue?
Sorry, sir. I don't really get that simultaneous. Can you just do it as if you're trying to find R?
Yes. Trying to find R.
That's
Okay.
instead of saying that
The
it's a simultaneous equation.
We have two equations with two
Yes,
unknown.
Yes,
now,
sir.
we want to make sure that one of the unknown is known before the other. So how can
Yes,
we
sir.
do that? One after the other. That is the
Yes, sir.
essence of simultaneous equation.
All right,
Simultaneous
sir.
equation says you start one after the other. Are we there?
Yes, sir.
Now, to solve simultaneously, you look for a way to eliminate one of the unknown. So how can we eliminate one of the unknown? While I was explaining, I made mention of what? Addition, subtraction, multiplication, and division. Those are the 4 arithmetic operations that you can use to eliminate one of the unknown in this question. So looking at the board, we have A and R product together. So it shows that what, for me to separate A and R, I will have to divide A and R out of the what? The equation on the board. So that tells me that what? For me to what? Solve these two simultaneously. That is A and R multiplied together in the first equation, A and R multiplied together in the second equation. Then that means I will have to what? Combine the two of them together by what? Dividing the two equations. We have same unknown. They have same missing value, and they have same value that they need to assign to A and R. So for me to do that, I will have to divide both of the equation together. If at all I have A and R to be having an arithmetic operator of A plus R, then that means I won't be dividing the two equations. I will only be using what? The opposite sign of plus. That means I'm subtracting the two equations instead. I hope I've made myself clear.
Yes, sir.
All
yes,
right.
sir. Thank you.
So from here, is it well clear to you now? Very well clear.
Yes, sir.
Okay. The absence of no contribution, I can move ahead to what we have for today. And today's class is focusing on geometric progression of infinite sequence. I think someone was trying to say something there. I'm all here.
Okay,
Hello?
sir, please, can you come again?
Can I
didn't
what?
really get what you explained. Please, can you come again?
Come again. Okay, a
Yes.
question was put on the board. And the question requests us to look for the first term. Now, finding the first term from this question, we have to solve them using an idea of simultaneous equation. Now, the question says the second term and the fifth term of a geometric progression are given as 6 minus 48. So that tells you that what? The second term takes the value 6 and the fifth term takes the value minus 48. So express them using our GP formula. We know that to get the second term, that is AR raised power 2 minus 1, we end up having to be what? AR. And this AR is assigned to what? 6. To get the fifth term, which is AR raised power 5 minus 1, is end up having AR raised power 4, which is assigned to the value of minus 48. Looking at these two questions or two expressions, we have A present in the first one and the second one, R present in the first one and the second one, and we have two assigned value present in the first and the second one. So that tells you that what? You need the idea of simultaneous equation. Then solving simultaneously, checking the arithmetic operator between the two unknown. If you have a multiplication in between, then that means simultaneously you divide. If you have addition or subtraction in between, then simultaneously you add or subtract to get for unknown value. Have I made myself clear? Have I made myself clear to you, my dear?
Yes, sir.
Okay. Okay. We move on to the next concept for today, which is geometric progression of infinite sequence. We call them sum to infinity. Sum to infinity of a GP. Sum to infinity of a GP. Now, in this case, sum to infinity of a GP. In this case, it arrives from the sum of term of a GP. Remember, sum of term of a GP has two formulas guiding it. The first one says that what? For all value of R must be greater than 1. While the second one says that for all value of R must be less than 1. And today's class, sum to infinity, focus more on the second part of the equation that says for all value of R less than 1. Yes, sum to infinity is given a general formula that says what? A over 1 minus R for all value of R less than 1. Now, for any question that will be given to you, and the question define that find this geometric to infinity. Don't forget this formula. Find the geometric of this sequence to infinity. Don't forget this formula. Find to infinity the following sequence. Don't forget this formula. I believe I've made myself clear. Now, I will go over the past question and give us a typical example of sum to infinity. Then you can see that what this is what we are talking about today. Okay. Here's the past question. Yeah, see on page 80 here. Okay, yes. It says, find okay, here it says sum. The sum of an infinite progression. The sum of an infinite geometric progression is 2 whole number 2 over 7. And the first term is 4. What is the common ratio? What is the common ratio? Now, look at this question. This one already gave us sum to infinity, the value, and it already gave us the first term. Now, we are told to look for the common ratio. The only time you can agree that this question is also a sum to infinity is if you have your common ratio to be less than 1. So let's find our common ratio. If it is less than 1, then it is assigned as what? Sum to infinity. Finding that, we assign this formula. I said what? Sum to infinity equals to A over 1 minus R. From our question, sum to infinity is giving us 2 whole number 2 over 7 equals to our first term is giving us 4 divided by 1 minus R. Then we can proceed with our solution. To convert this one to a mixed fraction, sorry, to an improper fraction, we have 2 times 7, 14,
Please
14
take it
plus.
slowly, you're rushing. Sir, please take it slowly. You're rushing.
What did he say?
Sir, please
I'm
take
rushing.
it slowly. Yes, sir.
All right. Is it well clear up to this point where I have introduced those values for my formula?
Yes, sir.
Now I can proceed. Convert every mixed fraction into improper fraction. That is, you multiply this 2 with 7, then add it to this 2. you end up having what? 16 over 7 equals to 4 over 1 minus r. Then from here, the next thing we do is what? We cross multiply. And when we cross multiply, this is what we have. 16 in bracket 1 minus r equals to 4 times 7. Then here, 16 in brackets, I can divide both sides by 4. Yes. Divide. I have 4 in brackets 1 minus r equals to 1 times 7. So I can say 1 minus r equals to 7 divided by 4. Then automatically I can say that r equals to 1 minus 7 over 4. Then my final answer, which is LCM4, 7, sorry. LCM4, I have 4 minus 7. So final answer end up giving me a minus 3 over 4, which is my answer for my common ratio. Now, the word minus says what you are owing. The word minus means what? It is less than. The word minus means what? Something is missing. So that means R equals minus 3 over 4 is less than 1. And this is true for the expression. Is it well clear to everyone in the class?
I have a question.
Yes, what's your question?
Sir, is it possible for us to use the 4 to open the bracket?
Come again with your question, please.
Is it possible for us to use 4 to open the bracket?
Is it possible for us to use 4 to open the bracket? Yes, it is possible for you to use 4 to open the brackets.
Yes, sir.
It is possible for us to use 4 to open the bracket. Yes. Okay. Let me use this part here to show you that. Here I have 4 times 1 minus r equals to 1 times 7 is 4. So I open the bracket with 4. 4 minus 4r equals to 7. Collect like tens. Minus 4r equals 7 minus 4. Minus 4r equals to 3. Then divide both sides by minus 4. Then I have r to give us minus 3 over 4. And that's the same as our answer. Is it clear now?
Yes, sir.
All right. Okay, let me look for one more question to buttress our point for today's class. Okay. One more question. One more question. Yeah, I have. One more question. Okay. I have another page, the same page 80. Yes, question 60. Question 60. This one says that find the sum to infinity. Sum to infinity of the series 1 over 2 minus 1 over 4 plus 1 over 8 minus 1 over 16 plus infinity. Now, that's the question given to us. 1 over 2 minus 1 over 4 plus 1 over 8 minus 1 over 16 plus etc. Now, from here, you have a job to do, looking for the common ratio. It is the common ratio that will let you know if truly you can sum to infinity. So how do you find the common ratio? A common ratio says that the second term divided by the first term is always the same as the third term divided by the second term. So here, our second term is minus 1 over 4 divided by 1 over 2. You must end up having the same answer as 1 over 8 divided by minus 1 over 4. So let's solve. Our r end up giving us minus 1 over 4 times 2, which is the same as 1 over 8 times 4 minus 4 over 1. So here, 2 here 1, 2 here 2. 4 here 1, 4 here 2. So both of them is giving us minus 1 over 2 as our common ratios. Now, if these are giving us minus 1 over 2 as our common ratio, then for all value of r less than 1 has been what? Proven true. So we can assign the sum to infinity now for the question. Sum to infinity now says that a
Sir, please, the
over
board is not clear. We can't see it. It's blurry.
is blurry. Okay, let me make it very bold. Sum to infinity equals a over 1 minus r at this point now. Then sum to infinity, we can assign our value. The value a is the first value we have here, which is 1 over 2. So a is 1 over 2 divided by 1 minus the value of r is what we solved here. That is minus 1 over 2. Then from here, I can say that 1 over 2 divided by 1. Minus times minus change this one to plus 1 over 2. Then I can proceed to this part. Now, at this part here, I have sum to infinity equals to 1 over 2 divided by, let's add the denominator. The LCM there is what? 2. That is 2 plus 1. So sum to infinity end up having 1 over 2 divided by 3 over 2. Then here I can say sum to infinity equals to 1 over 2 divided by 3 over 2, which is also the same as 1 over 2 times 2 over 3. And our final answer end up to give us 4 over 3. So that is the sum to infinity that the question is asking us to look for. Is that clear, class? Any questions so far?
Hello, sir.
Yes, I'm with you.
Sir, the answer is not in the option.
The answer is not in the option. Yes, but
Yes.
the solution we arrive at, the solution we have been solving, we are using the right process. I am never
Yes.
concerned about the options given in your question. I'm only concerned about the right solution to be used. Now, let's go over
Yes,
the
sir.
solution and see if we can spot a mistake. Okay? Yeah, the common ratio we arrived at was minus 1 over 2. Then, if you add this man together, you will end up having 3 over 2. Now, 1 over 2 divided by 3 over 2 is also the same as 1 over 2 times 2 over 3. That means that the error is coming from my calculation here. So my answer is 1 over 3. 1 over 3 is in the option. That's correct. So 1 over 3 is the right answer. Is it well clear now?
Second,
Is it well clear?
Sanu.
1 over 3 is the right answer.
Yes, sir. 1 over 3 is the right answer, but it's not in the option.
Yes, that is what I've just spot. I spot my mistake now. That instead of me to omit 2 from 2, I multiply the 2 together.
Yes, sir.
Okay, let me look for one more question, then I'll end the class for today. All right, I found one. Same. It says find the sum to infinity of the following series. Okay, yeah, I will change the series here on the board. So here it says the series are 3 plus 2 plus 4 over 3 plus 8 over 9 plus 16 over 27 plus etc. Are we there? Find the sum to infinity of this series. Now, the first thing we did from the previous example was to look for our common ratio, and that is what we'll be doing here also. So, find the common ratio. A common ratio R equals second term divided by the first term, third term divided by the second term. So, let's assign our R. The second term is 2 divided by first term 3. Must also be the same as the third term 4 over 3 divided by 2. Then here I say 2 over 3 is also the same as 4 over 3 times 1 over 2. This cancels this, then our R remains 2 over 3, which is 2 over. Okay, I come again with the solution. Find the sum to infinity of the series. 3 plus 2 plus 4 over 3 plus 8 over 9 plus 16 over 27. That is the series. You find the common ratio first by dividing the second term by the first term, or the third term by the second term. Whatever you have here must be the same thing you have here, and must be the same thing all through. So here, 2 divided by 3 give me 2 over 3. But 4 over 3 divided by 2 will still end up giving me 2 over 3. Automatically, if I should say 8 over 9 divided by 4 over 3, I will still end up having 2 over 3. So, telling you that what? My common ratio is having a general value of what? 2 over 3. Then that helps us to define the sum to infinity. Now, sum to infinity says that S infinity equals to A over 1 minus R. Now, what is the value of our A? 3 divided by 1 minus what's our R? 2 over 3. Now, yes, sum to infinity says 3 divided by LCM there is 3. So I have 3 minus 2. So finally, I have 3 divided by 1 over 3. Then my sum to infinity equals to 3 divided by 1 over 3, which is same as 3 times 3 over 1. Then final answer end up giving us a 9. 3 times 3 is 9. So sum to infinity for this question is a 9. That is the answer from my solution. Going over my solution again to see if we can spot any error. 3 divided by 1 minus 2 over 3. 3 divided by 1 over 3. Then 3 divided by 1 over 3 is still the same as 3 times 3. And the answer is 9. Class, is there any question from any of you concerning what we have done today? Because this one will draw the curtain to the end of sequence and series for your session in Post-UTME 2025. Is there any question from any of you? Is there any question from any of you? It is advisable you open your past question. That is the essence of you having a past question. Look for questions before the commencement of the class. Read ahead of the class. I expect to be getting questions from you relating to what we have here. I still have extra question in my past question, in which I can bring out for us to buttress our point, if that's okay with you. If that's okay with you.
Okay, sir.
Your question? I can hear you loud and clear. Oh, I think I lost it there. Okay, while waiting for your question, let me do a quick review of what we are talking about in class. Maybe that will give you an idea of what to ask. We are talking about a sequence and series. What are sequence? Sequence are array of numbers. Numbers like 3, 2, 4/3, 8/9 are sequence, separated by commas. They are called sequence. What are series? Series are also arrays of numbers, but these ones are separated by arithmetic operator of plus and minus. So you can see that one from the previous question. They said, find the sum to infinity of the word series. The essence of the word series there says it is separated by arithmetic operator. If it is not separated by arithmetic operator, you will see the word sequence or progression there. That is how you can differentiate that word, sequence and series. How do you differentiate AP from GP? An AP is an array of numbers that uses arithmetic operator of plus and minus, having a common difference in between your terms, while a GP is an array of numbers that uses arithmetic operator of times and division, having a common ratio between the terms. I hope I've been able to justify and simplify or differentiate the difference between AP and GP, sequence and series. I leave you to look for more questions before the commencement of next class.